Dr. David Wood gave Bournemouth Humanists a talk on transhumanism a couple of years back, in which he claimed that in theory there was no obvious limit to how long someone might live. And indeed, he predicted that in the quite near future, lifespans of over 120 years for some might not only be possible, but even commonplace. And he's here today to discuss his reasons for his optimism. Now, David is chair of London Futurists, co-founder of the Transhumanist Party UK, a fellow of the Royal Society of Arts, and he holds an honorary doctorate in science from Westminster University. He's also the author of 4 books entitled Smartphones and Beyond, The Abolition of Aging, Sustainable Superabundance, and Vital Foresight. So, welcome to Humanistically Speaking, David, and thank you very much for joining us.
It's my pleasure to be here.
Thank you. Right, first of all, can you tell us what is meant by the term transhumanism? I've never heard of that before.
Trans means beyond. Transhumanism says that the goal for humanity is to go beyond our current human condition, that the ideal state for us is not to be like some imagined past period of time, some golden age in the dim and distant past, nor even just to bring everybody up to the level of the good life today. But there is a much better life possible in the not too distant future if we wisely take advantage of what science and technology is making available for us. So we could live significantly longer and healthier, we could be much smarter, our emotional states could be much better, and our political and social realities could be much better.
Well, that's fascinating. That's so optimistic in these times. That's quite refreshing to hear. But how did you get into this area in the first place?
Part of my introduction to transhumanism was in my professional career, where I was for 25 years, a figure in the early days of the mobile computing and smartphone industries. This is before Apple's iPhone and Google's Android changed the world. There were earlier smartphones from companies that older viewers may remember, called Nokia, Ericsson, Motorola, and so on. And these ran software that the company I co-founded, Symbian, created. We could see that smartphones were changing the world in a significant way. We could see that smartphones, when they worked well, could make their users smarter. But it was clear to me that this kind of change was likely to be followed by other technologies in the not too distant future. So not just that we would be reprogramming our digital companions, our PDAs or our smartphones, but we could in due course be reprogramming ourselves via genetic updates. And that artificial intelligence was going to make many more things possible to us. So that's how I became interested in this subject. And I discovered there were a small group of people in London who were meeting in Penderel's Oak pub in Holborn one Saturday morning a month. So this is back in 2005. And I got in touch with them and have never looked back.
I know that pub well. I've been there many times, but I didn't know about the group that met there on Saturday. Did you say Saturday mornings?
No, I'm sorry, Saturday afternoons.
Oh, Saturday afternoons.
Yes.
I might well join them.
Well, it's moved. It moved to Conway Hall, and more recently, before COVID, this is. I would organise meetings in Birkbeck College, which is quite close. But since COVID, there hasn't been any real world meetings, and instead we've been meeting online instead.
Okay, well, thank you very much for that background. So it's almost kind of by accident, almost, you just got into that area. But you described the 4 industrial revolutions. I was intrigued by this because 4 industrial revolutions. You said the first one was essentially steam and mechanization, then electricity, chemicals and mass production, followed by computers and electronics. That was the third. And finally, the fourth that you refer to as NBIC. Would you like to explain what you mean by NBIC and how the NBIC age might trigger research into delaying the age process?
So first, let me just say about the Industrial Revolutions itself, which has changed human society more dramatically than any other thing that's happened in our history. If you look at metrics such as the number of people living in poverty, or the average life expectancy, or the average GDP per person. Most of these metrics remained relatively flat for most of history until taking off in sometime from about 1760 onwards, different countries at different paces of time. So the Industrial Revolution has arguably changed society more than any of the antics of kings or queens or politicians, and more than wars have done. So it's given us lots of possibilities. Now, the next thing is, well, is this Industrial Revolution just one blob and that's all there is to it? And historians differ on this, but I agree with the analysis that many people have that the Industrial Revolution itself does come in various phases. And so there was a new life to progress from about the 1880s onwards with the invention of the telephone, better buildings which could have lifts inside, the creation of synthetic chemicals, and the harnessing of electricity. The third industrial revolution has been when we have gradually seen computers displacing more and more people from the workforce. There has been also cellular communications. And what's next? And it's harder to see this for sure, but I agree with futurists who talk about NBIC as 4 different things which are converging together. So the N stands for nanotech, the B for biotech, the I for infotech, and the C for cognotech. Nanotech means more precise control over the layout of factories at the nanoscale. So this isn't just creating static things like semiconductors, which are marvels of the third industrial revolution, but things that can actually move and manufacture. This is the full vision of nanotechnology. Biotech I've mentioned already in the intro when I mentioned about reprogramming our biology. And we can do that more and more, not just by the way of manipulating our genes, but manipulating our epigenome or manipulating our biome, which is the bacteria that's in our gut. Infotech is machine learning. It's not just computing more than before. It's not just storing more than before. It's actually having software that works out by itself what the patterns are. And so this is what's different from deep learning compared to the AI that preceded it. And that has come ahead in leaps and bounds since 2012, in fact, when there was the annus mirabilis, when various deep learning algorithms outperformed in computer vision what had been possible previously. And from then on, every year, every month almost, has led to miraculous changes in the ability of deep learning. Cognotech, sometimes called neurotech, is the ability to reprogram our minds, our brains, as we understand the brain more fully, as we can scan what's happening inside our minds without needing to cut our heads open. We can understand what's happening when we are thinking in various ways, when we're being creative or intuitive or meditating and so on. And all 4 of these reinforce each other. So as we have better nanotech, as I mentioned, we can understand what's happening in the human brain better. When we understand the human brain better, we can copy some of these ideas into artificial intelligence. And then with better artificial intelligence, we can design drugs better. And we can discover new uses for old drugs by working out in a simulation what may be possible. So your question was, what's NBIC? It's still early days for this 4th phase of the Industrial Revolution. I expect it to keep becoming more significant in the next couple of decades, but it is giving us more possibilities to address aging than ever before. So we can talk about nanobots, which are small programmable pieces of robots, if you want to call them. They would fit inside the bloodstream and they could travel around the body and identify damage and either remove it or in some cases repair it. So that's one thing that nanobots can do, nanotechnology can do. Then with infotech, we can, as I said, figure out in advance which drugs are likely to be most effective. And a very recent case of infotech giving us new insights in biology was with DeepMind's AlphaFold technology, which was able, in an unexpected way, to accurately predict the 3-dimensional shape of proteins, given just a 1-dimensional set of codes for the amino acids that would form into these proteins. And it's been a long unsolved problem to figure out how these things will fold in 3 dimensions. And why is that important? Well, the biological properties of these proteins depend on their three-dimensional structure. And when you can do that, you can anticipate more clearly in advance the consequences of various drug interventions and so forth. So in all these ways, these steps of progress can assist the cause of undoing aging.
I think that's absolutely fascinating. I mean, the opportunities and possibilities seem to be endless, absolutely endless. I'm going to have to brush up on my understanding of DNA to follow everything that you've said. But yeah, I mean, is it all positive, or is there a potential dark side to this, do you think?
So transhumanism has been clear from the beginning that there are dark possibilities lurking in amongst all this pace of change. After all, each of the industrial revolutions has had dark consequences. We've had the dark satanic mills, the terrible suffering that the factory life introduced with, in the end, you can say it created a better economic life for most people, but along the way, it had lots of hardships. And of course, the end consequence of that first industrial revolution with the burning of coal and later the burning of oil is still with us, with the risks of climate change. So there is something called the Transhumanist Declaration, which dates from 1998, which is 8 clauses of a proposition for what can happen in the future. But 4 of these clauses sets out risks and points out that if we're not careful with these technologies, we won't necessarily get the benefits we're hoping for. And there could be bad side effects. Just one more example, a current one is that if we are manipulating genes to try and understand viruses more carefully, for example, and it is reasonable that people will think, well, viruses might mutate, so how could we prepare something in case a virus mutates? Well, there is a risk that if you are experimenting with mutated viruses with extra capabilities, this is so-called gain-of-function research, that some of these viruses might escape. And that's one hypothesis for the origin of COVID. It's disputed, but it's by no means a non-credible scenario. So there are risks. There are, as we are better equipped at bioengineering, then people will intentionally or unintentionally create pathogens which are worse than any we've had previously.
You mentioned earlier the Transhumanist Declaration. I thought you said 1898. That can't be right. It's 19.
I meant to say 1998. Yes.
All right. Okay.
No.
I'm sure you did. I just got that wrong. It's all right. It's 1998. That Transhumanist Declaration. I think that's worth looking up. So we'll pursue that. Just to move on a little bit, then, you talk about the cycle of technological disruption in the sense that sometimes a development in technology causes ripples, like a stone in the pond. That's the way I think of it. And that has far-reaching consequences before a new order is established and progress slows down. It reminds me of a theory of biological evolution that's known as punctuated equilibrium. And I'm struck by the similarity between the two. Has that ever occurred to you?
So before we had this discussion, I don't think this comparison had occurred to me, but I agree. They are both examples of the fact that progress is not smooth. And although at a certain level of abstraction, you can draw a curve, a simple exponential curve, and say this is the Industrial Revolution. It started slowly and then it's getting more and more hectic. There are phases in between. And it's likewise with the historical or prehistorical evolution of the species. It's not that the rate of change is constant. It is hypothesized, changes in circumstances when maybe a small population ends up in an isolated island where it can mutate and evolve more quickly, and therefore the pace of change is not constant, but it depends upon various things happening to get things into new configurations that were not possible before. That's certainly the case with lots of technology. Again, from far enough away, it just looks like technology is getting better the whole time. But when you come in closer, you find, oh, this got held up here until somebody had a breakthrough, which allowed a different kind of chip or a different kind of disk drive or a different kind of piece of software. So even inside smartphones, I would say that there was phase one of smartphones with companies such as BlackBerry RIM, Palm in America, and Symbian and Cyan in Europe, and a few others, and we were overtaken by much more powerful software and hardware systems of Google, Android, and Apple and iOS. So there's a jump up there, which at first seemed like it was going nowhere. And that's often the way that at first what turns into a technological breakthrough seems disappointing and underwhelming. It turns out that the first smartphone that Steve Jobs was involved with was a total disaster, and most people have forgotten about it. It was a joint project between Apple and Motorola. It was called the Rocker. It had Motorola hardware and some Apple software from their iPod software music system, and it ended up having the worst of both worlds. So it was a flop in the market, and both Steve Jobs from Apple and Mike Zaworowski of Motorola had a public falling out about it. But then Steve Jobs decided, well, in that case, they have to do it all by themselves rather than in a partnership. Even then, several of their iPhone projects were cancelled in-house before he was confident enough to break through with a particular choice. So that took longer. And I think it's the same with many of the transhumanist technology breakthroughs. People will talk for a long time about the possibility of significantly extending human longevity before it turns into a reality.
Yes, I'm one of those people that thinks that failure is kind of unripe success. It's you know, you can't have success unless you have a few failures and deal with them on the way. Just to come back to the question of aging, there is an element here. I mean, aging is just a fact of nature, isn't it? I mean, for example, my car will get old and rusty after a while, and it'll eventually become worn out and dilapidated. Now, that's the norm, as I understand it. And I mean, what I'm trying to say is that we're not meant to grow old. Nature would have found a solution by now, surely, to the question of if we were meant to live longer, that we would have, nature would have resolved that already. Isn't there a cycle there that nature needs to progress, to evolve?
It's a good question, but I would say that just because something is natural doesn't mean to say that we should support it and take that as our limit. After all, if we look at what was natural for most of history, was that people could expect to live maybe about 30 years, that most families had many children dying before the age of 5, many women would die in childbirth somewhere along the line, and that was natural, but medical doctors said, we can do better. And thank goodness medical doctors said we can do better. We had things like the contraceptive pill, which is not remotely natural, but we're glad to take advantage of it and transform family lives and women's education and so forth. The example of the car is good too, because there are cars that were created 100 years ago without any thought that they would still be running 100 years later. The parts maybe had a 10-year lifetime expectation, but they were lovingly restored and repaired many times over, and so they're still running today. So that is what the philosophy of anti-aging imagines, that yes, our bodies do by nature have some limits in them, but we can repair the bodies in ways like repairing the car. And by the way, the body's nature does have repair mechanisms built into it, and when we are young, the repair mechanisms work well. If we fall over as a youngster and skin our knees, they recover pretty well. If we do the same thing much later in life, they can take a lot longer to heal because the repair mechanisms have got damaged themselves. So one of the main approaches to rejuvenation is to repair the repair mechanisms. That doesn't sound too daft. And so the stem cells that are in our body, which can give rise to other kinds of cells, if we can introduce new stem cells, these stem cells in turn can repair many other aspects.
Yes, I've always been fascinated by stem cell technology. I once asked my dentist if I could actually grow new teeth. And he said, well, there's studies going on in, I think he said Japan, but there's not been any major breakthroughs. So apparently the tooth grows as an amorphous mess. But they're working on it, and it's encouraging. They might have resolved it now. I don't know. Well, I think that's fascinating. So, has there been any progress in the study of super aging?
Super aging is a particular concept, which is that some people live old,
Yeah.
but they are pretty decrepit, but others are remarkably healthy, even late in their 90s.
Yeah.
And a super ager is sometimes defined as somebody who is at least 95 and who hasn't had any serious bouts of cancer, heart disease, stroke, diabetes, or dementia. And there are such people. And remarkably, they often come in family groups or in communities. And so we should study what's unique and special about these groups of people. And there are two schools of thought. One is that it's their lifestyles that are significant. And many people have studied the lifestyles of these super agers, and they have drawn a few conclusions. The main thing is don't eat too much, of all the diets. If we eat too much, it's bad for us. So some kind of intermittent fasting or occasional fasting is good for us. That's the main takeaway from all that. Other people will draw other conclusions, but that's the top level conclusion.
That's
But
right. Sorry, go ahead. I'm sorry to interrupt. Go ahead.
No. I mean, I could talk all day about this. You need to interrupt me from time to time.
No, I was just thinking. I've read about this. That apparently, if you live a life where you practically starve yourself, you can actually extend your life very considerably. That's been known for some time. But then the question is it worth starving yourself just to live a few years longer so that you can carry on starving yourself?
This is the theory of calorie restriction. And I would say there isn't actually any conclusive proof that calorie restriction works in humans. It works in other animals such as rats and mice and fish and a whole host. But testing it in primates takes a lot longer because primates live a long time. And the only two experiments with calorie restriction in primates gave inconclusive results. One was sort of spoiled because one of the lab assistants felt sorry for the primates that were being starved, and she, out of the goodness of her heart, fed them extra. So that sort of invalidated a project, so I'm told.
Terrible.
But there are people who swear by calorie restriction, and I think what's happened in the last 10 years or so, maybe 20 years, is an understanding you don't need to starve yourself all the time. So what I do is 5 days a week, I will have a much less diet. So I will still eat. I will eat something like 600 or 800 calories, whereas the normal intake for a male is supposed to be about 2,400 calories. I will take about 800 calories in these 5 days a week. And the other 2 days I overindulge, so I probably shouldn't eat quite so much. But and there is evidence that pushing your body into a different mode on these other days helps it to repair and recover. So what I eat is carefully chosen, so that it gives me the essential nutrition. And there are many people who look at different things. There's a fine book by James Clement called The Switch, which looks at a lot of these scenarios and possibilities, and points out that different people will react to diets in different ways. Some people just can't cope with intermittent fasting of one sort, but a different sort. Maybe some people go 16 hours a day without eating and they just have one big meal in a day. And it goes against what our grandmothers told us. You need to have 3 good meals in a day, and breakfast is the most important meal. Turns out that's more of a myth, that we can do very well just with one good meal in the day. So that's in terms of lifestyle. But the most interesting thing is in terms of genetics, because some of these super agers, dare I say it, they didn't have healthy lifestyles at all. So there's a famous family of 4 Can siblings, each of whom lived to more than the age of 100. And 2 of them lived to 109 or 108 3/4. And one of these who lived so long, she smoked most of her life. She didn't like to eat vegetables. She was asked, well, didn't any of your doctors tell you to give up smoking? And she said, yes, but all 4 of them have died over the years. She had outlived them. Now, the motto of this is not that you should smoke. The motto is that for most of us, we should live in a healthy way. But there are some peculiar genes, as this kind of family of siblings seems to possess, which seem to give an extra advantage. Now, people are trying to figure out what these genes are, and it seems like there's not just one, but there might be 3 different sets of genes to do with control of cholesterol. There's many different kinds of cholesterol. One of them is to do with insulin-like growth factor. I don't claim to understand the details of that. And there's another one to deal with the pace of metabolism inside some cells. So this hasn't yet borne complete fruit, but there's a researcher at the Albert Einstein College in New York. He's called Nir Barzilai. He's written all this up in his most recent book, which is called Age Later, which means we'll still age, but if we do this, we will maybe be 20 or 30 years later. And the argument isn't that we will somehow necessarily reprogram these genes of these super ages into ourselves. That's one possibility, but more credibly is once we understand what these genes are doing in terms of the proteins in our bodies, because that's what genes do, they generate proteins inside cells. Once we understand that, then we can introduce these proteins and these other elements of biology into our body via various treatments. So that's the vision there.
You mentioned this family that had enormous longevity, and you're able to say obviously they're dead now, but presumably there are still studies going on with their offspring, with their children.
Yes, well, the offspring don't always live so long. So because the offspring have a mixture of genes from them and their non-super longevity.
Yeah, of course.
So that's often the case that the very oldest people, their children, sadly, sometimes die even before then. So, so they might live into 109 and their child dies at 85 or something. So you're right. It is a complicated issue, and I don't want to give any impression I think this is simple. It's a massive engineering problem. So the solution of aging, undoing aging, will be one of the most complicated projects we've ever done. But after all, the design of smartphones is incredibly complicated. The design of a Boeing 747 with all its hardware and software is enormously complicated. So I think the design of the right set of treatments that will allow us to be rejuvenated is likely to be one of the hardest projects we've ever undertaken as a species.
So, I mean, I was going to ask you if there's any particular stumbling block that's in our way regarding reversing of aging. But it's beginning to seem that there are so many different strands, it's almost impossible to talk about one specific problem.
Well, there are stumbling blocks we should be aware of. One is that it is a complicated issue and it's going to take a lot of effort. It's also a mindset issue. There are many people who just somehow feel we shouldn't go there. You know, it's natural. I think most people have got two attitudes deep inside their minds. One part of their mind says, it would be nice to live longer. I like living. I don't want to shuffle off this mortal coil anytime soon. But there's another voice that says, don't be selfish. Everybody else has died. You've got to make way for the next generation. It's immature and egocentric to think that you deserve to live longer than everybody else. So we've got both of these instincts inside of ourselves. And I think, sadly, the one that says, let's embrace aging as something we have to accept, that's still too prevalent. And I want to help change this attitude. Now, maybe it made sense for most of history to accept that because there's nothing you can do about it. There's no point wishing for something that's totally beyond possibilities. But when something is within our possibilities, then it's a different matter. There is this famous prayer by Reinhold Niebuhr, the German theologian, which is often quoted, God, give me the grace to accept what I cannot change. Give me the courage to change what I can change, and give me the wisdom to know the difference. So at this stage in history, with the technologies of the fourth industrial revolution at our disposal, with the insights as to how the diseases of aging are caused by aging, then we should flip some of our mental attitudes and get many more people studying this and researching it. And this mental attitude is probably going to make the biggest difference about whether we go fast to the abolition of aging or it takes a long, long time.
Yes, you do talk about the society having the will to do that. And if they have the will to do that, they can possibly make some amazing achievements over the next even 10 or 15 years. I think you indicate.
That's my view, yes.
So is there any particular, at the moment, is there any particular exciting research you can point to that's into reversing aging that you're aware of?
Well, there's many lines of research, and each of them target one or more of the types of damage that's in our bodies. So let me try and explain one of them. It's called epigenetic damage. So it's not the genes inside our cells that go wrong, but it's rather the marks on the DNA. And when I say marks, it's little chemical groups called methyls or ethyls. And the reason these things are there is to stop various genes in various cells expressing the wrong things, because we've got the same DNA in almost all of our cells, but that means that in the heart cell, there is a gene to create skin cell proteins and so on. Well, we don't want that turned on inside the heart. And so the epigenetic markers control which genes are on and off at different times. But as we age, some of these markers get displaced, and so instead we'll get strange things growing in our skin or growing in our heart or all over. We have cells which are no longer quite so well tuned to where they are. So is this something we can do something about? Well, it turns out there was a discovery about 20 years ago by a Japanese researcher, Shinyo Yakamata, that if you put 4 proteins into a cell, they would undo some of the epigenetic aging. It's remarkable. He got the Nobel Prize for that, along with biologists at Oxford who'd done some earlier work on the same ideas. Now, the problem is if you do that too much, you end up with a cell that loses all of its knowledge. It goes back into a much more primitive state. After all, the cells we had when we were much younger, they weren't heart cells or skin cells. They were more general, pluripotent cells with the ability to become anything. So if you put too much of this in, you will do damage. And so the question is, can you put the right amount of these Yamanaka factors in? And this has fascinated people for the last few years. And there has recently been a large investment into a new company called Altos Labs with amongst its funders, Jeff Bezos, one of the richest people in the world. So they have invested billions into this new Altos Labs endeavor, which is looking at what can be done with this epigenetic reprogramming methods. So they're not going to tackle aging itself first, but they're going to tackle various diseases of aging. And so I think they're applying it to, if I get this right, I may have got some of the details wrong, there may be diseases in the eye which result from over epigenetically aged cells in the retina. And with this treatment, you can undo that and you can restore good eyesight. As I said, I may have remembered the details of that wrong, but if it's not that, it's something similar in that there's a particular part of the body which can be treated in a particular way. And the idea is that when we develop more mastery of this technique, it will give us the ability potentially to rejuvenate many of the cells in our body. So that's one interesting line of research. I could also mention senolytics. Senolytics is to deal with senescent cells. A senescent cell is a cell that has almost died but hasn't died and stays in the body in a zombie-like state. And it's not bad that cells in our body die. It's sort of natural process. And normally the body says, okay, this cell has stopped working, and it hoovers it up and it recycles the materials. And that's part of the natural repair mechanisms. But after a while, the repair mechanisms don't quite work. And we end up with these senescent cells, which are bad news because they're sending out help signals. They're saying, help me, please, immune system, come and get rid of me. But the immune system's not able to do that. And so if you get these senescent cells, it's bad news. And as we get older, our body has more and more of these senescent cells. And that's where senolytics comes in, which is a way to encourage the body to be more aggressive at removing these senescent cells. We don't want it to be too aggressive because there's a balancing act. But if you can get that balance right, then we can move forward. And there are significant number of companies now researching these senolytic treatments.
That's a new word for me, senolytics. I'm going to look that up. Thank you very much for that. One thing that you said that triggered a thought in my head. You were talking about cells, say in the heart, that you can reverse the aging process, but you don't want to reverse it too much because the cells lose their memory. That's what you said.
Well, they won't be heart cells anymore. They'll be precursors of heart cells. Which
is that the same as stem cells?
There are many kinds of stem cells. So there are heart stem cells, but there are also precursors of heart stem cells, which are pluripotent stem cells that can become many kinds of cells. So the memory they'll lose, maybe it's a loose word, it's just the fact that they're meant to be a heart cell as opposed to a different kind of cell.
I understand that. I just think that there seems to be potential there too. I thought one of the problems with stem cells was actually getting stem cells, getting enough stem cells to actually make any difference. And I might be quite wrong with that because I'm not into this.
No, I think you're right. We can get
but
general stem cells easily enough, but often what you need is your own stem cells. You don't want to have stem cells from another source. So ideally, we should be able to have some of our own cells taken away and grown large and then injected back into our bodies. And that's quite a difficult process.
So if you can extract cells from someone and grow them, for example, in a Petri dish or whatever,
yeah,
and then reverse the aging process, you could have an endless number of cells in theory, I suppose, that you could use as stem cells.
Yes, that's right. So there are many variants on that possibility, and people are checking out different possibilities. Yes.
Oh, that's extraordinary. The possibilities there seem enormous. Well, that's really fascinating. So let's get on to the effect on the planet of the population. We know that David Attenborough, for example, feels very strongly about that. So let me ask you, if everyone lived until they were 120 or plus, wouldn't that be an impossible burden for the world's resources? I mean, it's difficult enough as it is with all sorts of constraints on food, fresh water, energy, and the biosphere. What would need to change? What would we need to do? I mean, if there's going to be an enormous growth of population, or would we stop having children? I mean, how would you envisage that?
So I share with David Attenborough deep concern about the effect of human life on the environment, but I don't think population itself is the biggest determinant of that influence. It's rather the kind of lifestyle that people have. And we can have more people, but if they live in a greener way, and if there's more recycling of waste, then we can have less impact on the planet. And this isn't just idle talk. There is some evidence. I point to a recent book by the MIT economist Andrew McAfee called More from Less. He talks about a new enlightenment, and the kind of enlightenment he means is things are actually getting lighter, that tin cans have got less tin in them, that farms are able to grow more food from less land. And so in many parts of the world, we've already gone past peak usage of many materials because we're able to achieve more from less. Now, I don't want to be complacent. There are many big environmental issues remaining, as Andrew McAfee also says in his book that I've mentioned, but it shows that there are possibilities here. As you pointed out also, the biggest determinant of population is probably the size of families rather than the age where people die. But I don't want to be naive here. I think that if people were to live much longer, the population would get larger. But I think the Earth could look after many more people. And a big part of that change will be transforming agriculture so that we no longer give large parts of the land over to growing crops to feed to cattle, which we then slaughter and eat as meat. But instead, we will be much more efficient in growing meat in laboratories, so-called cultivated meat or cultured meat. And there are many advantages of cultivated or cultured meat, but one of them is use much less land, fewer greenhouse gas emissions, use less fresh water, require less use of antibiotics because the labs themselves will be germ-free. So there are many ways in which we humans can have a larger population but have less impact on the environment.
Yes, the question of artificial meat is quite an interesting one. I think I read something. I mean, they've actually produced artificial meat, or they've grown it in the laboratory, and they boasted the most expensive hamburger in the world, I seem to remember.
It was, and it's less expensive now. It's come down in cost quite a lot, but it's still more expensive than the normal hamburgers, and it needs more work, and it doesn't taste quite as nice as a normal hamburger because, I mean, meat's got multiple textures in it, and these artificial meats don't yet have all the textures, but maybe, we'll be satisfied with something that doesn't taste quite the same because it'll have other sauces or whatever. So I do envision that quite soon we will look back at our present practice of eating meat, real meat, slaughtered meat, I should say, with some disgust, much as we look back at Victorians who send little boys up chimneys with disgust.
You've not actually eaten this meat yourself, have you? You said it didn't taste so nice.
I'm just referring to what other people have said.
All right, yeah.
There are lots of people who track this industry. It is, I think, very transformational. By the way, a lot of what it uses is the same biotech innovations that will also be applied in helping humans to live much longer. The transformation of genes, the manipulation of cells.
Right. Okay. Well, there is just one other thing then. I mean, sometimes bringing the changes can be very useful for any society. I mean, if we have a set of old people with old ideas running the world, I imagine social change and development might be very slow, mightn't it? I mean, perhaps it would even stop entirely. For example, if the Victorians lived to 120 plus, good social change like women's suffrage, respect for LGBTQ people and attitudes to mental health, AIDS maybe, and the environment might be very different today if social progress was slowed down by a world that was controlled by large numbers of older people voting for other older people. Isn't there a danger there?
So there's certainly a problem if we had people who were rejuvenated in body, but didn't get rejuvenated in mind as well, if their minds remained fixed and set in their ways. Your question echoes a famous phrase by the German physicist Max Planck, who said that physics progresses one funeral at a time, that you had to wait for an elderly physicist to die before people could think new thoughts. It turns out that's quite a wrong assessment. It turns out that many elderly physicists are able to think new thoughts. It used to be thought that most physicists got the Nobel Prize for work they did before they were 30. Well, it turns out more and more physicists and chemists and other scientists are getting the Nobel Prize for work they did later in their lives. So all we need to ensure is a fluidity, not just in our health of our bodies, but a fluidity in the health of our minds. And there are, you and I surely do know people who are quite elderly, but who have very nimble minds and who are able to change their attitudes. It used to be said that grandparents would never get smartphones. This is what I was told long. And now I see grandparents, great-grandparents using smartphones all the time in a marvelous collection of ways. So it is possible for minds to rejuvenate as well. And in case it needs some help, then there can be social rules put in place, such as there's a rule in America that says if you've been the president for 8 years, that's all. So even though Barack Obama was still healthy and probably would have been the best choice for president in, what was it, 2016, the rule was no, he had to stop. And other rules like that could be put in place to ensure some turnaround as well.
Yeah, I mean, I do agree with that. I think that's a very good answer. Thank you, because I think it's part of the human condition, isn't it? You know, the ability to change and to adapt and to change your point of view. And speaking personally, and maybe you would share this view, I feel just as creative, just as imaginative now as I was 50 years ago. I mean, but then that's a personal reflection. Maybe other people would say something different. But yeah, I think this idea that people kind of lose their edge when they reach a certain age, I think is a bit redundant. It's wrong. It's not right. It's not right.
It can happen, but it's by no means an iron law. And I think we owe it to ourselves to keep reinventing ourselves and helping those around us to be nimble and reinventive as well. Absolutely
agree with that. I think that's a great way to end this conversation, because yeah, that's still positive, and it's positive for people like me at the age of 74 that there's still a future and I can still grow. Is there anything? I mean, my questions have finished. I mean, this has been a wonderful interview for me, a real eye-opener, because this is an issue, a subject I don't know anything about. I didn't until I spoke to you. Are there any issues that you'd like to make yourself? Any other points that you'd like to make before we close the interview?
Well, welcome viewers who want to find out more, joining London Futurists events from time to time. They're held online for the time being. They look at subjects such as the future of artificial intelligence, the future of politics, the future of humanity, the future of climate change, not just in a a classic or traditional way, if I can say that, but we're looking at more radical ideas and trying to assess, are they credible, and what's really desirable. And so I encourage people to figure out which of these meetings, if you're interested, you'd like to join. And that's one way to continue these discussions. And I've written up some of the arguments we've shared just now in the various books, such as Vital Foresight, which is my most recent book, which is also the longest book. So it's quite a weight. It's something like 642 pages. But people who read it say they were disappointed when they reached the end because they wished it had gone on longer. So that's a good commendation.
Well, that's I can't say better than that. But if people wanted to find out more sort of online, is there any particular email address or anything like that people could use?
You can reach me at davidw@deltawisdom.com. There are many Davids in this world, as we know, so I stuck a W at the end of my email to slightly differentiate me from at least some of the other Davids.
There's far too many Davids, if you ask me.
It's a very popular name from 5, 6, 7 decades ago.
Yeah. Anyway, I thank you so much, and thank you for this interview. I've thoroughly enjoyed it, and I've learned so much. I think when we put this in the magazine, I think we should identify the NBIC elements, because I think that was particularly important in text, so that people can actually read that. But anyway, David, thank you very much.
It's been a great discussion.
Humanistically Speaking is a volunteer-run online publication slotting in the gap between National Humanist glossy magazines and Humanist UK's newsletter. We aim to create a platform that can bring humanist groups and individual humanists together, of course, but also to allow non-humanists to join in the debate. We want to explore topics of interest that any freethinker will be concerned about and offer informative, factual articles that encourage people to reflect upon, explore, question, and share ideas. We are in an exciting marketplace of ideas, and it is important that humanists from all stables of opinion have a voice. Humanistically Speaking is unique in offering this. Our remit is constantly developing, and by the start of our second year, we grew from a bi-monthly to a regular monthly issue. We've also expanded from email communication only to launching our own website and created our first values publication, From Atheism to Humanism. All of this has been made possible through your donations and your goodwill, and we're deeply grateful to those supporters among you who have donated already. But this is just the beginning. Our aim is a bold one. In addition to offering our support to National Secular Society and Humanist UK's campaign objectives, we want to share the humanist idea with everyone in society. Naturally, we want to celebrate rational thinking, open inquiry, compassion, fairness and justice, but we want to balance these good things with enjoyment and having fun, a sense of comradeship, and the thrill of just being alive. But to go further, we need financial security, and we're asking you to help us. If you approve of what we're doing, please join us on our journey towards the foundation of a national humanist magazine that lends voice to every rational and respectful opinion. We want to explain and celebrate what humanism is and share humanist ideas that we believe can do so much to improve the way we all live. You can help us to achieve these aims by setting up a standing order of £4 a month or whatever you can afford to Humanistically Speaking, or if you're not able to do that, think about giving us a kickstart boost by donating a one-off lump sum of perhaps £20. Our bank details are at the bottom of this screen. But if you prefer, please click on the link below that will take you straight to the appropriate place on our Humanistically Speaking website and follow the guidance given. Every donation will be acknowledged with a message of thanks from us. One last thing before you go, do spread the word with your friends, because Humanistically Speaking is there for everyone. There are also many potential humanists out there who already share our values and yet don't know we exist. There are also humanists who don't have a group nearby and who might be feeling like a lone voice in their communities. We would like to serve them also and play our part in breaking down any sense of isolation. We're doing all we can by committing our time and energy. Please help us with your goodwill and donations and join us on this journey. Thank you.